Welcome to Science and Engineering World, where we do mathematics, more mathematics, much more mathematics. In this presentation, we want to look at the derivation of one important formula in algebra, which is almighty formula. My name is Olutola Fakehinde. Almighty formula, yes, that is the name. By the time we finish with this presentation and some few examples, we will see that it is truly an almighty formula. And this formula is used to find the roots of a quadratic equation, just like this. This is a standard form of a quadratic equation where x is the variable, a and b are coefficients, and c the constants. We now use this quadratic equation to derive our almighty formula. There are 4 different methods we can use to solve quadratic equations. The first one is the factorization method. The factorization method is quick and good. However, it has its own limitation because not all quadratic equations can be factorized. The second one is the graphical method. The graphical method is also good. However, the accuracy of generating the data and plotting the graphs can have effects on the results of the quadratic equation. The third one is the completing the square method. This completing the square method is good and you can use it for almost all quadratic equations. However, it is long. Because it is long, sometimes people want to use a shorter method, and the end result of this completing the square method is what is called the almighty formula, which is also good and very fast, simple and fast. So let us see how to derive this almighty formula with this simple basic quadratic equation that we have here. In deriving the almighty formula using this basic quadratic equation, we are going to do some transformation through this equation. And step 1 is to divide the equation by the coefficient of x squared. And what is coefficient of x squared? Coefficient of x squared means we have ax squared. If we remove this x squared, what we have left will be its coefficient, and that is a. So we now use the a to divide the expression through as this. In this expression, we say that the first term, the a will cancel out, and then the last term, which is on the right hand side, which is also going to be 0. And this equation is therefore transformed into this x squared plus b over ax plus c over a equals to 0. Call it equation 1. The second step is to separate the variable from the constant. And like I said earlier, once there is x, it is a variable. And the one that has no x is a constant. So we see that c over a is a constant. So we have x squared and b over ax, because x is involved, have variables, and c over a is a constant. And so we want to move the c over a, that constant, to the other side of the equation. In that case, we have to subtract c over a from the left hand side and also subtract it on the right hand side. In this, we now see that The first one, C over A on the left hand side, we cancel out because we are subtracting. So this we cancel out, and we now have the equation in this form: x squared plus b over ax equals to minus c over a. Step 3 in this derivation process has 3 operations to do to this equation 2 we have here. That's the one we derived above. And the 3 operations are: number 1, take the coefficient of x and half it. That's number 1 step. Number 2 is square it. And number 3 is add to the equation. So let's look at this process one after the other. So the first one is have coefficient of x. What is coefficient of x? Like we said, if we remove x, not x squared, x, we are going to have b over a. So the coefficient of x is going to give us b over a. Then we're going to do half of it, so which means we multiply b over a by half. And that gives us b over 2a. Then we square it, which is the second operation. So we square this, we square that to give us this. And then the third operation is add to the equation above. So we are going to add this to that. And that will give us this equation, which is x squared plus b over ax plus b over 2a in bracket x square equals to b over 2a in bracket square minus c over a. This process is known as the completing the square. And we'll see how useful this is as we go on. Step 4 and step 5 are very important. So we have this equation 3 which we have derived above. So to equation 3, I want to look at these two sides. The left hand side, this is left hand side, and the right hand side separately, and then bring them together. In processing the left hand side, we want to factorize it. So we factorize the left hand side. And in factorization is looking at the product of the coefficient of x squared and the constants. So the product of the coefficient of x squared will give us 1 because coefficient of x squared is 1 here. And this is the constant. So we have 1 times b over 2a squared. And this will give us b over 2a squared. We want to find the factors of these products. And looking at it, we say if we say a squared is going to give us a times a. That is, the factors of a squared will be a and a. That is a twice. So also here the factors of b over 2a squared will give us b over 2a and b over 2a. That is b over 2a twice. With this, what we want to do is we want to find a way of getting the coefficient of x here. Now, with b over 2a, if we take b over 2a minus b over 2a, we are going to get 0. So that will not work. However, if we do b over 2a plus b over 2a, we will see that we are going to get b over a. That is, b over 2a plus b over 2a will give us b plus b over 2a, which is 2b over 2a. And that gives us b over a. With this known now, we can now split this the x here into 2. so that we get that. So we now split the x into 2 by doing b over 2ax plus b over 2ax will definitely give us b over ax. With this known, then we can now combine the first two terms and the last two terms. So looking at the first two terms, we find out that the common factor among them will be x. So on the first one, x will go in x squared to give us x. X will go in b over 2ax to give us b over 2a. So that will be the first bracket there. So the plus we have to come in there. What is common to the last two terms will be b over 2a. So if we take b over 2a out, we now see that b over 2a will go in b over 2ax to give us x, and b over 2a will go in b over 2a squared to give us b over 2a. So we have that for the second term. Once we find out that the two brackets are the same, then it means we are on the right track of factorization. Now we can take one of the brackets and combine it with the outside terms. So b over 2a, which is one of the brackets, we can have it down there. B over 2a, we are factorizing it. We have x plus b over 2a. And this will give us x plus b over 2a squared. Putting the left hand side into a square bracket. And that was the beauty of what we did in step 3. In this step 5, we want to look at the right hand side of this equation 3. So right hand side here. And in the right hand side, we want to perform two operations. Number one is to open the bracket. That is, open this bracket. That's the first operation. And the second one is to simplify. So the first one, open the brackets. In this case, we are going to open the bracket by multiplying what is inside twice. So we have b over 2a bracket multiplied by b over 2a. In that case, we are going to have b multiplied by b to give us b squared, and 2 multiplied by 2 to give us 4, a multiplied by a to give us a squared. This is what we get when we open the bracket, and we can put it into that expression there. Now we need to simplify this further because we want just one term, not two terms in this case. So we simplify b squared over 4a squared minus c over a. Here we need to find the least common factor or least common denominator to be able to simplify. And the least common factor and least common denominator here will be 4a. So 1 times b squared will give us b squared. Then we have the negative sign there, minus, and then a in 4a squared will give us 4a. 4a times c will give us 4ac. We can now put this into that expression there to give us b squared minus 4ac over 4a squared. Step 6 is very easy. All we need to do is to bring together both the left hand side and the right hand side. So the left hand side we obtain to be x plus b over 2a bracket square, and the right hand side we obtain to be b squared minus 4ac over 4a squared. So we combine these together to give us this expression 4. In step 7, we now want to find x. And we have seen from the equation 4 that x is inside this bracket here. And it's a bracket with a square. For us to be able to bring out the x, we now first of all have to find the square root of the left hand side so that we can take the square out. But once we do the square root for the left hand side, we must do the same for the right hand side. And so we have this. So we now want to simplify the left hand side so that we can take x out. Simplifying the left hand side now, square root of a squared is the same thing as a squared bracket 1 over 2. 1 over 2 is square root. So in that case, we have a squared times half. So 2, we take 2 out, and that will become a. So the square root of a squared is a. So the same thing we do here. We now find here that this is the inside bracket. Then the square root is the power of half. Taking the big bracket out, we see that we can now multiply the two powers together, and 2 will take care of 2 to give us x plus b over 2a. So now we are free to be able to find x. Because we have square on the left hand side, we must get 2 roots of this equation. And this is why we have to put in place the plus and minus sign, so that we'll be able to get 2 roots of the equation. In step 8, we are still in the process of getting x out. Now, before we finally get x, let us look at the right hand side. We can also simplify the right hand side. In simplifying the right hand side, we have the square root of the numerator and the square root of the denominator separately. Because in the denominator, we can find the square root of 4 and the square root of a squared. So in that case, we now have b squared minus 4ac in the square root of the numerator, and then the denominator will become 2a, because square root of 4 is 2, square root of a squared is a. So this makes our expression above to be x plus b over 2a equals to plus or minus b squared minus 4a all into roots and then 2 over a. So we're almost there. Step 9, which is now getting our x. In getting our x, what we need to do is to take away the constants on the left hand side so that it can go to the right hand side. And to do that, it means we have to subtract b over 2a from the left hand side and also do the same on the right hand side. And we now have b over 2a on the left hand side. We cancel b over 2a. And so we now have x equals to minus b over 2a plus or minus square root of b squared minus 4ac over 2a. This step 10 is our final step. And what we want to do is to simplify the right hand side further so that we have one term instead of 2 that we have there. And it's very simple because the two of them have the same denominator. And once they have the same denominator like what we have here, these two can be written as minus b plus or minus q over y. So same thing, we can write the above because they have the same denominator as x equals to minus b plus or minus b squared minus 4ac over 2a. Now this is our almighty formula. And what we have inside the roots there, which is b squared minus 4ac, is the discriminant, and it determines how the roots of the equation is going to go. When we go into solving some problems, we'll be able to see this in action. And so finally, we have our almighty formula, and that is x equals to minus b plus or minus square root of b squared minus 4ac over 2a. And this formula can be used to solve any quadratic equation. Remember, we obtained this from the basic quadratic equation: ax squared plus bx plus c equals to 0. And we did completing the square method to be able to arrive at this almighty formula. So both methods, that is the completing the square method and the almighty formula, can be used to solve quadratic equations. And we shall demonstrate this in more videos after this. If you find this video very useful, give us a thumb up, and at the same time share to others. Make comments so that we know how far we've gone with this, and if you need any further clarification, let us know in the comment section below. At the same time, keep subscribing. Subscribe if you have not done so. We need to make this solution to go to the other part of the world, so this will help us. And I always say this: you can find a joy in doing mathematics, and so keep having fun. And lastly, keep studying.